Alright, so 6-2 brings us into our beginning properties of quadrilaterals. And specifically today we're going to talk about parallelograms. And then from parallelograms we're going to branch off into even more specific types of quadrilaterals. So, read the first 4 questions and answer what you think they should be. Okay, so supplementary angles are 2 angles whose measures sum to what? To what? 180. Suppose that angle x and angle y are supplementary. If the measure of angle x is 75, then the measure of angle y is 180 minus 75, which equals 105. A linear pair is complementary or supplementary? Supplementary. Over here, angle AFB, so AFB, this angle here that's 60 degrees, and EFD, this angle that's 120, are complementary or supplementary. So that's just kind of a review that supplementary angles do not touch. They do not share a side. They're not considered vertical, by the way, because they're not created by 2 intersecting lines that are straight. But they are supplementary. So supplementary angles and complementary angles do not have to share a side. So you have to add up for supplementary to 180 and for complementary to what? 90. All right, so then we have some vocabulary we're going to use today. And today's big vocabulary word is consecutive. So consecutive angles, consecutive things are one right after the other in uninterrupted order. So on a polygon, consecutive angles, you can go clockwise or counterclockwise to become what they are. So like A and B are consecutive, B and C are consecutive, or A and F are consecutive. But A and E are not consecutive because they're interrupted. They have to be right next door to each other. So look at 5 through 7, and I want you to determine what angles are right next to each other. So draw a line here. And so those should be your answers there. A belongs, or A is consecutive to angle F. Angle C is consecutive to angle D. And angle D is consecutive to angle E. What's the consecutive month after April? 2 of them. May, and then June. December, November, October. Why is that one harder? It's backwards. So what's the month that comes before September? August, and then July. So that was uncomfortable, right? But they're still consecutive. All right, so flip that. Look at all the theorems. Yay, these should go on flashcards. And we are going to build, and I'll get you something tomorrow to help you start building this. I just didn't want to give it to you today. I thought it would be too cumbersome, so we'll use it tomorrow as a review. But we're going to build a visual aid that will help you keep track of these. Me personally, if I were you, I would put each of these theorems on a flashcard and start to identify which ones they go to. If it's specifically to a parallelogram, to a rectangle, to a rhombus, to a square, we're going to look at all different kinds of quadrilaterals. And the very basic quadrilateral that we're starting with is a parallelogram. And so, theorem 6.3 says if a quadrilateral is a parallelogram, so the parallelogram, then its opposite sides are congruent. What figure do you know whose opposite sides are congruent? Always. Name a figure, a quadrilateral, whose opposite sides are congruent other than a parallelogram. A square or a rectangle. So oddly enough, a square and a rectangle belong to the parallelogram family. We'll learn more about those later. They're just special parallelograms. But not all parallelograms look like a square or a rectangle. But if it is a parallelogram, opposite sides will be congruent. If it is a parallelogram, then consecutive angles, one right after the other, are supplementary. They're not equal, they're supplementary. What is equal on a parallelogram would be opposite angles. Opposite angles on a parallelogram would be angle D and B, or angle A and C. Those are opposite angles. So I know that the whole angle from here to here, or the whole angle, I can get that on here to here, those are equal. And we already know from our previous section that the sum of the interior angles add up to what? 360. 4 minus 2 times 180 is 360. And then the last theorem here says if a quadrilateral is a parallelogram, then its diagonals bisect each other. The diagonals bisect each other. So you can see diagonals drawn into this parallelogram here that I just marked up. And all that says, or all that means, is here's one diagonal from A to C and from B to D. The diagonals connect opposite angles. That means that this piece from A to E is equal to this piece from E to C, and this piece from B to E is equal to this piece from E to D. Notice that I did not single tick mark all four pieces. All four pieces are not equal to each other until later. When we get more specialized, a more special parallelogram, then they will become equal. But in just a plain Jane parallelogram, they bisect each other, but these pieces are equal only and those pieces are equal only. They're not all four equal to each other. Alright, so number 10, we are to mark the parallelogram to model 6.3 and 6.5. So I showed the opposite angles being congruent. I did not show the consecutive angles being supplementary, but you can see that they're different. There's no way to model that with tick marking or arc marking. And then segment AE is congruent to what? EC or CE. And then BE is congruent to what? ED or DE. Use proper notation. The minute you're told a parallelogram, all of these things you're supposed to have in your brain. If that's all these things for one parallelogram, and then in 2 days we're going to move on to a rectangle. The rectangle is going to have a new set almost as much as this. Aren't you going to start to get confused? You are. So you have to start to learn them. So between now and Wednesday, you're going to have all of this learned and all of your formulas from the previous section learned. Otherwise, you're going to get overwhelmed. So let's look at some problems. So problems involving consecutive angles. Suppose you adjust the lamp, you can see the lamp at the right, so that the measure of angle S is 86 degrees. So here's angle S right here. And this angle here is 86 degrees. Currently it's 64 though, right? Oh, it's hard to see in here, but here's the parallelogram that they're trying to show you. From here to here, here to here. So when they say angle S, do we know which angle they're referring to? Well, they currently have angle S marked as 64 degrees, But this could be angle S down here, this outside. So let's continue. What is the measure of angle R in PQRS? I find that amusing that they put 64 degrees in there. I'm going to get that to this one. Well, let's walk through this. R and S are what to each other? Are they opposite angles or are they consecutive angles? They are consecutive. What do you know about consecutive angles in a parallelogram? They're supplementary. So R and S are consecutive angles, so they are supplementary. There's your connection. Consecutive angles are supplementary. You're always trying to make connections in your brain. And so therefore the measure of R plus the measure of S should equal what? 180. Now find the measure of angle R. So we've got the measure of angle R plus, we're going to change this. I'm going to change that to 86. My assumption is that that was supposed to be 86 degrees and it's not on the outside. And so we're going to put 86 degrees here in place of S, and that equals 180. So if I subtract 86, what do I get? What do I get? 94 degrees. And does R look like it could be a slightly obtuse angle? Yeah. It's iffy, but yes. So there's a measure of angle R right there. Let's look at a proof. Because you have two proofs, at least two proofs on your homework tonight. So use the diagram to write, and they tell you some things about it. Given, and they're telling you that it's a parallelogram, ABCD. That's the markings right there, parallelogram. That's what this means. So you know all of the theorems about a parallelogram. In addition, they tell you that segment AK is congruent to segment MK. So this segment here is congruent to that segment there, the whole segment. We have to prove that BCD, this angle here, is congruent to CMD. This angle here, we have to prove that this angle here is congruent to that angle there, somehow. All right, so let's watch how they go about it. So circle the classification of triangle AKM. So the overall outside triangle AKM, what kind of triangle is it if this side is equal to this side? So it is isosceles. Don't we know a lot of stuff about isosceles triangles? What do we know about isosceles triangles? The base angles are congruent. Where are the base angles here? The base angles A and K, A and M, or K and M, if these are the congruent sides. Aren't those the two base angles? So I can already say that angle A is congruent to angle M based upon the fact that I have an isosceles triangle. And what do you know about these angles here based upon the fact that this is a quadrilateral? Opposite angles are what? Congruent. So let's watch them walk through. So AK is congruent to something that was in the given. So what would that be? That would be MK. Exactly as the given gave it to you. And then angle DAB. So DAB right here is congruent to something. The angles opposite congruent sides of the triangle are congruent. So what's the opposite angle to DAB? This one here in the triangle. They are saying that this is congruent to this because it's following the sides. I'm going to use the same exact angle that they've used here because that's what I'm trying to prove. I could name it KMA if I wanted to, but I'm going to use that same name here because that's in my proof. I could have used KMA or KMD or CMD or reverse of any of those, so long as M's in the middle. But I'm using angle CMD because that's what's in my proof statement. We don't have to say that we have an isosceles triangle to use that. We just have to say this, which is in the isosceles triangle pair. Then they go on to say that BCD is congruent to blank because opposite angles of a parallelogram are congruent. So what's opposite to BCD? Yeah, and I'm going to use, it's not my proof statement, so I don't need it. So you can say BAD or DAD, it doesn't matter. I'm going to say BAD because I like that word. All right, then finally, what's always our last statement? Our proof statement. So we want to write it exactly as our proof statement states. So BCD is congruent to CMD because of the transitive property of congruence. Let's see if I actually agree with them. Let's see if I would have used this reason. So look at how they wrote it. The transitive property, remember, says that A equals B. Then whatever you ended up with here, you must start with here. B equals C. And then take away what they have in common, and you have A equals C. That's the proper use of the transitive property. Did they do that here? This equals this. They didn't start with this here, did they? No. So what should we use instead? Not reflexive. If they don't follow the transitive property, what do we usually use instead? Substitution. So please change this to substitution product of congruence. That's not the proper use. And you might want to put in here, they did not the proper pattern. Okay, so let's do some problems in our book, just related on those, because that's most of what your book is going to be dealing with. Either opposite angles are congruent, or consecutive angles are supplementary, or you might have a proof related to the properties. So open up your workbook to page 151. And let's start here with these first three. And I personally want you to find all four angles in the parallelograms, not just the angle marked X. So I want you to find all four angles. So on number one, you're only missing two angles. And what do you know about these two angles? They're congruent because they're opposite. So I know that this angle is equal to this angle. Notice how these are opposite angles and they're what? Congruent. And it is important that you realize that they told you these are parallelograms in the directions, otherwise you can't assume it's a parallelogram if it looks like one, unless they're hidden in the parallel. And so what's the measure of angle X? So 120 degrees. Why? Consecutive angles are supplementary. So those should add up to 180, so 180 minus 60 is where we got the 120. And so now we have this angle. What's this angle here? Also 120. So I want you to find all four angles in 4 and 5 using those properties. And so you're doing this on your own. So when you get your answers, I want you to share them with those around you. So you're only doing 4 and 5. All right, so here's your answers for 4. For number 4, these two are equal because they're opposite. So if that's 35 degrees, that's 35 degrees. And then these two are adjacent, so they're consecutive. And so they should add up to 180. So I took 180 and subtracted that 35. You should have gotten 145. That means if that's 145, the angle opposite it is also 145. And then same thing down here. If that's 27, this is 27. These are adjacent, so they're also consecutive. They should add up to 180. You subtract 27 from 180, you should get 153. And so the opposite angle is 153. So let's look at the proof. Now the proof deals with diagonals. Now remember that your diagonals, what did I do with my notes? Your diagonals here bisect each other. So the conclusion is if they bisect each other, you have some congruent segments. So look at what they did with their proof. Parallelogram EFGH, that's a given. So everything that we know about parallelograms so far is a given. With diagonals EG and HF. So I know just from the fact that it's a parallelogram that this is congruent to this, and this piece is congruent to this piece. I also know that opposite angles are congruent and that consecutive angles are supplementary. We need to prove that triangle EFK, so EFK here is congruent to triangle GHK. Don't those triangles also contain a vertical angle at K? What do you know about vertical angles? They're congruent. We also know that opposite sides in a parallelogram are what? Opposite sides in a parallelogram are congruent. So aren't these sides here congruent as well? Won't we be able to prove the triangle's congruent by SSS? We could also prove the triangle's congruent by SAS. Let's see how they progress the proof since they've given you part of the statements and part of the reasons. So your given should be here, and the entire part of the given needs to go in there. They don't have the given split up. So parallelogram E, F, G, and H, that's part of it, along with diagonals. Segment EG and segment HF. Then the second reason says the diagonals of a parallelogram bisect each other. Notice that down here they have EF is congruent to HG. So we don't have, that's not the diagonals. What do you think is going to go here? We're trying to prove triangles congruent, because remember this last statement is going to be our proof statement. So this very last statement right here is going to be triangle EFK is congruent to triangle GHK. And so far, all that they have given us is this is a side length over here. This is a side length. Diagonals bisecting each other has nothing to do with angles, so I'm guessing that this has to be side length and perhaps 2 of them, since I need 3 sides to prove triangles congruent. Didn't we end up with 2 pairs of congruent pieces from those? So that's what needs to go there. So segment EK is congruent to segment AG, and segment HK is congruent to segment KF. That gives us our side. Plus then those pieces are equal. What is EF and HG to each other? Okay, so that means that we're going to put in here opposite sides of a parallelogram are congruent. And finally, how did we prove those triangles were congruent? SSS. So you're going to use prior knowledge in your proofs. So you have this as an example. I believe that there is a different proof in your textbook other than, this might be the same proof. Let me just double check. Nope, in your textbook, you have actually two different proofs as well. So you can also look at these proofs. So look at this one. So here we have they just tell you it's a parallelogram. And in this parallelogram, they only give you one diagonal, but we know we could draw another one. And your job is to prove that segment AB is congruent to segment CD, and segment BC is congruent to segment AD. And all you're given is that it's a parallelogram. So look at how they progress with their proofs. You start with your given. Then, by definition of a parallelogram, aren't opposite sides congruent? Or congruent, aren't opposite sides parallel? And so that actually might be something we might want to add to our notes because that wasn't specifically in your notes. What is it? So pull out your notes. And right up here at the top, we're going to add something in because I think you should add a flashcard associated with that definition. There are parallel lines in the word parallelogram, by the way. So the definition, oops, can't see that. Definition of a parallelogram would be opposite sides are parallel. So we can use that as well. And I'm totally fine with you using that as a reason in a proof. So let's go back and look at this proof. So just based upon the fact that they gave us a parallelogram, we can immediately conclude that opposite sides are parallel. So notice that they did choose opposite sides. We're trying to get to the opposite sides being congruent. We're trying to prove that theorem here, so we can't use that theorem in the proof. And so then angle 1 is congruent to angle 4. Aren't these parallel lines here? Aren't those alternate interior angles on parallel lines? And if these lines are parallel, aren't angle 2 and angle 3 also alternate interior angles? And so that's why they've used this. If lines are parallel, then alternate interior angles are congruent. And so now we've got angle, right? And then they say that segment AC is congruent to segment AC. Isn't that a shared side of these two triangles? And isn't that the reflexive property of congruent segments? And so now we have a side. Is it AAS or ASA? This is congruent to this, so let's mark it up. This is congruent to this. This is congruent to this, and then the sides are congruent. So just look at one triangle. Is the side included or not included? Included or not included? Included. And so that's why they're using ASA. So they immediately say that the triangles are congruent, and then by CP/CTC, corresponding parts of congruent triangles are congruent. Aren't any corresponding parts congruent? And so then they've chosen to use the proof statement because those are corresponding parts on those triangles. And so there's another proof that you can look at. And then, finally, there's one more. flow-through proof. Bless you. So this will be proof number 3. I just chose not to make you write them all down, but they're available for you to look at. So on this proof, again, you're only given that you have a parallelogram, and your job is to prove that A is congruent to C and angle B is congruent to angle D. Aren't those opposite angles? Well, they're proving that theorem in the proof, so we can't use that theorem in the proof. So look at what they've done. So we start with what we're given. Based upon what we're given, we can use the fact that consecutive angles are supplementary. So they've said that A and B are consecutive angles and B and C are consecutive angles. They've used a reason saying that they're a definition of consecutive angles. So, aha, there's another progression. And in addition to that, C and D are consecutive angles. You'll see why they need all 3 here in a minute. And then consecutive angles, by definition, are supplementary, aren't they? And so consecutive angles are supplementary is your reasoning for that. And then if 2 angles are supplementary to the same angle, aren't they congruent? So if 2 angles are supplementary to the same angle, these 2 angles are supplementary to angle B. Doesn't that mean the angle A and C are congruent then? And then these 2 angles are supplementary to the same angle, meaning C. So that means that A and B are congruent. And isn't that what we're trying to prove? So if I were you, I would make a note in my notes to perhaps study that one, because that's a good proof. All right, so your homework tonight is on the board.